Hi, my name is Vadim. I'm the head of application department of CENOS, the affordable platform for engineering simulation. We integrate the open source tools into the simulation workflow and provide user-friendly interface for it. Now, I shall show you how to create a geometry using open source tool called Salome, which is integrated in CENOS platform. We shall create the geometry of a simple printed circuit board, we shall call it PCB, designed for the laboratory experiment. So first, when you open CENOS, you see the case directory selection. By default, it is in your home directory /CENOS/case with the date on the end of it. I will use this default one. Click continue, and you are now in the workflow. It consists of pre-processing, computing, and post-processing. Today we are working only on pre-processing. Hit add preprocessor, click Salome, you have Salome block appeared, and click play, and Salome will start. It will take maybe up to 10 seconds. Yeah, it's ready already. So now you have to create a new document and enter one of two loaded modules. So mesh module or geometry module. Today we'll work in geometry module. So in Salome we shall create the geometry and the mesh and export it to CENOS. The tutorial for mesh creation is the separate video. Please find the link to it in the description to this video. Within this video we shall create the geometry for PCB model like on this picture. You see it consists of 7 slits and 6 chips on it. Slits are here only to modify the heat flux. So in order to create this geometry, we have to fulfill 2 important steps. First is the creation of basic objects of the geometry. So let's say the geometry itself. The second is creation of groups, and these groups will allow us later to create boundary conditions and define materials and apply them to specific domains. I'll start. Let's click this create a box button and input dimension of our epoxy board in millimeters. So 110, 20, 1.5, apply and close, and this is our epoxy board. In order to rotate it and move around, you will have to click this mouse button, and then you are able now to rotate it, to move it around and see from different angles. You can also see that there is a box 1 object appeared in your tree viewer or object browser. You can toggle its visibility by pressing this eye icon. Now to create slits, I will use points. I'll create 2 points now, 16, 4.5, 0, this is XYZ of the first point, hit apply. You have now vertex 1 appeared here in object browser. The second is 18, 16.1, 1.5, apply and close. Now you have 2 points, vertex 1, vertex 2. Again, click this create a box button, but in this case do not input any dimensions, but choose the second option, which allows us to create the box by means of 2 diagonal points. So point 1 is vertex 1 and point 2 is vertex 2. Apply and close, and now you see this slit. It's rectangular now, but we'll make it rounder. Now by means of this modification menu, where you have fillet 2D, fillet 3D, chamfer, we'll use this fillet 3D. We can fillet some edges. There are 3 options. First is filleting on a whole shape. Let's say if I input now 0.5 millimeters, for example, the main shape would be box 2. See, it will fillet all the edges. Second is filleting selected edges. Third one is filleting selected faces. I'll use filleting selected edges option. Edges would be that one, that one. To select multiple edges, you have to press down your shift button. So 0.5, let's change it to 0.8, apply and close, and this is what we've got. That's our our slit shape. Now we need 7 of them. In order to do that, we'll have to use the transformation menu. Here's transformation, translation, mirroring, rotation. We'll use this multi-translation. So step is 12.62 and number of times is 7. You might wonder, how did it guess the correct direction? Actually, it didn't. It just has default vector of x. But if I choose a vector, let's say y, well, set to look like that, and I can also do it like that. So you don't actually choose a vector, you choose any edge which is parallel to this, to your desired direction. So let's choose this edge, and this is what we need. I have 7 slits. They are all in one object called multi-translation 1. I usually do not change names of objects which I know that will not be used in final mesh. Therefore, I leave them default, but if you want, you can change the names to, let's say, slits. Now I will need to use these slits to cut out the slits of the epoxy plate. We'll use this slit menu. So the main object is not slits, it's box 1, and the tool object is slits. Click apply and close, and now you see our resulting object is cut 1, and it looks just like that. Now in Salome, you have to remember that if you have created a solid object like the cut 1, you do not have immediately access to the surfaces. In order to have this access, you will have to create them. There are other options, but I will use this one. So click New Entity, Group, and create a group. And in this way, I can extract points from this volume, or edges from this volume, or surfaces from this volume. I'll need surfaces, and I can just manually click this surface. I will use it to extrude it for 0.035 millimeters and create a thin layer of copper on top of this epoxy plate. So I choose it. Now I click add. I have this surface, it's number 20. Hit apply and close. And now under cut 1, I have group 1, which is face, only one face. And I will use it to extrude now. So let's click this group 1, click this extrusion button, and extrude it. Vector should be Z. The height should be 0.035 millimeters. Apply and close, and now you see I have on top of my epoxy plate, I have very thin layer of copper. That is just fine, except that I need chips. For chips, or actually first there will come solder layers. I will use again point method. 22.964, 6.8, 1.535, apply. Have this vertex tree now. Here will be 26. It's 13.2 and 1.5 9, 8. Applying close. Again, I have 2 points. I will use them to create box. Applying close. So this box is my solder layer. Again, I will use multi-translation. 12.62, 6 in this case. I can leave vector blank because you see by default it's 6 direction. It fits for me. Applying close. I have 6 solders under chips. Now I'll have to place the silicon chips on top. For this one, again, we will have to create surface groups. Let's do surface. Yeah, main shape is multi-translation 1. That's correct. 1, 2, 3, 4, 5, 6. Add, apply and close. Now this under this multi-translation 1, I have this group 2. Let's call it solder upper surface, but as I said, you can leave the default name. And now let's extrude it to, so the vector is again the 6. You see, apparently this edge has different orientation. If I choose this edge, I see it's in the other direction, but you can always change direction just by extruding in negative. So let's put minus 0.2, and that's just actually what we need. Yeah, sorry again. That one, and now on top of my solder, I will have now 0.2 millimeter thick chip, silicon chip. Applying close. That looks good, but there's another thing what I would like to do before we go to group creation. I would like to modify a little bit my copper and my epoxy in order to have possibility of mesh extrusion later. Now I have on copper I have non-matching surfaces. Top surface has this chip on top, which means that upper surface actually is not this one large surface, but is this one large with 6 smaller surfaces in it, and the lower surface of copper is just one single surface, and it doesn't allow me to make extrusion because target surface and source surface will not match. For this reason, I will create now for this solder the bottom surface group, create group. Sorry, it's not cut one, it's multi-translation one. We can make cut one invisible. And now let's select them. 1, 2, 3, 4, 5, 6. Add. Let's name it solder lower surface. Apply and close. Now let's extrude this one to downstairs. So base is solder lower surface, vector is this one, and so it will be minus 1.535. Apply and close. And now the last step, which I have to do before creation of groups, is partition. It's required because if I'll go now to meshing, my different volumes, for example, copper and an epoxy, they are actually only touching each other, but they are not like glued. It means that, for example, copper can have mesh which is not matching to epoxy mesh. For this reason, I have to select all my relevant domains, go to operations, partition, and just apply and close. Now the partition is actually the only thing left which we'll use to create mesh and create geometry. So now we have done the first part, and the second part is creation of groups. We'll start with volume groups, which is just easier. New entity, group, create group. So, and now we should input the names, because these names will be actually used later. So main shape is partition, and to create volume groups we'll use the geometrical parts of the second shape, and the second shape is cut1. Cut1 is our epoxy. Select all, and these are 6 volumes. This is exactly what I expect, that one large and 6 these are 7 volumes, one large and 6 of these extruded chip volumes. So this will all be epoxy. Apply. The next will be copper. This extrusion 1. I just say select all, and it selects everything what's inside here. Again, 7. Apply. Third is solder. It's multi-translation 1. Select all. Now there are 6. Apply. Now silicon. Extrusion 2. Select all. Again 6. Apply and close. So now we have 4 volume groups. We will only have to create now surface groups, which will be used for creation of boundaries and boundary conditions. Now let's start with surface group for epoxy, but main shape still is partition 1. Just this time for surface we select this only subshapes of the second shape, because area is a subshape of the volume. So epoxy, select all. Now it has selected all the surfaces which belong to epoxy, but some of them will not be used to apply a boundary condition. For example, those which belong to copper. So I select now copper, say select all, and I see there are some highlighted. These highlighted are those belonging to copper, and I can remove them. If I now remove them, you can click apply and close and actually make all the rest invisible and see what we have got. Everything looks fine except these inner rectangular surfaces. I will remove them now. I'll say edit group, just click here, Control A, so that I have selected all of them, show only selected, and I can now manually remove those which are not necessary. I'm still not sure, maybe there is some more effective way to do this. If you know it, just please let me know. So this is the 6th one. Remove. Control A, show only selected. Yeah, that's fine. Now apply and close. and this was actually the group name was epoxy surfaces. Cool. Now next group is group for copper surfaces. Subshape is copper. Select all. Now let's select everything that belongs to epoxy. You see they are highlighted. Remove. Also we can select everything that belongs to solder. Select all. Remove. Apply and close. And these are copper surfaces, and see it's thin, and you see that actually it's the same problem what we've got with epoxy. We'll have to edit it and remove. So again, select 1, 2, 3, 4, remove. So luckily we have only 6 chips, so therefore it would be nice if we could do it in a different way. So sorry, 1, 2, 3, 4, remove. 1, 2, 3, 4, remove. It's fixed. 3, 4, remove. 1, 2, 3, 4, remove. So now let's, sorry. Apparently I have removed one that I didn't need to. Let's remove that. Yeah, and now I'll have to select again this top surface. Just let's make the copper visible again. Let's try all subshapes. Yeah, and let's select this one and say add. And show only selected. Yeah, that's fine. That's just what we need. But here we've got another one which we can remove. Yeah, that's always a little bit tricky, such manual geometry selection. But finally it's done. Apply and close. Now the last two will be just a bit easier. So now the group for solder surfaces. Subshape is this multi-translation one. Select all. Now remove everything that belongs to just everything that belongs to copper. Select all. Remove everything that belongs to silicon. Select all. Remove. Now apply and close. And now you see these are 6 rectangular surface loops. That's what we expected, because top and bottom surfaces of solder are covered with silicon chip and copper. Now the last what we need is surface group of silicon, but we will split it. We'll split it. I'll show you what I mean by that. We will split it because we'll split it in two, because side surfaces have only heat exchange, convective heat exchange, and the top surface is also used for heat generation or heat input in the model. So now let's select all, remove, apply and close. And now let's see what does this has. Yeah, exactly, it does has side surfaces and also top. We will remove these top ones. Control A, show only selected. Now let's unselect 1, 2, 3, 4, 5, 6. Remove, apply and close. Yes. And now the last one is group creation. So it's silicon heating surface, and these will be subshapes of silicon. And let's select them 1, 2, 3, 4, 5, 6. Add, apply, close, and now we're done. So we have created now geometry and created all the groups. The last step, what we have to do now is save as. Let's go to our working directory. PCB model RTF. Save, and we are done. Here was volumes from CENOS. We created the geometry of PCB using open source tool Salome, which is integrated in CENOS platform. Please see the following video for measuring and further steps of simulation workflow. You can find the links of these videos in the description to this video. Thank you. Bye.